Hi guys. Good evening. Am I audible to all? So today is our day 6, right? Can someone just confirm that I'm audible and the screen is visible? Particularly the Zoom guys. I'll just cross check once with the YouTube guys also. Okay. Yash has confirmed that it's audible. All good. Yes, guys. Good evening, everyone. Those who have joined through YouTube. So let's start now. Okay. So I am on my Eclipse me. Okay. So we finished with uh, binary search, right? Now, I wanted to discuss one very important question on binary search. Very interesting scenario it is. Okay. So let me just check. Yeah, see over here. So it's there in the folder. Let me just check. Okay, so this will help you immensely while you all go for logical problem. So help you all immensely. Yes, I just want you all to be with me. And I'm explaining the. So it was day 4. Yeah. So this we had done, right? Yeah, this one. So we finished with the first one. So today, hopefully, we should finish up with the searching part, and then we'll start with the next data structure. Maybe we'll start with a stack, or we'll start with a priority queue. Okay, but we go in a way that we all benefit from this session. I'll not go so fast. So see, this is a question which says you are given an array A consisting of n positive numbers. So the array consists of positive numbers. Each integer represents the number of players from a country. So let's say there are 4 countries. Okay, so the length of the array is the number of countries. So we have 4 countries. Let's say it's an IPL, and we have 4 players from Australia, 3 from England, 5 from South Africa, and 3 from West Indies. So we need to form teams, and each team should be of size K. So if the K is 3, each team should have 3 players. But the question is they should be from different country. Okay. So if my K is 4, for example, that is my K is same as the length of the array, then how many teams can I form? Okay. So you have to give maximum number of teams which can be formed. Okay. So our question is how many maximum number of teams can be formed? So we will be using binary search logic over here. Okay. Even though you might feel that where is the capacity to insert binary search over here, but we will be using binary search. Okay. So let me go to the paint and then try to explain this question better. Okay. So given an array of size n, so n is 4. So I have array length as 4. And each integer represents the number of players from a particular country. We need to form teams of size k such that all these k players are from a different country. No player from 2 countries mm, there should be no players from the same country in the team. So one team cannot contain people of two national. Okay, there should be no two Indians in a team. There should be no two Australians in a team. So each team, all the players should be from different nationals. So let's try to check this on Paint. We'll try to first understand the question. Maybe then we can try to decode the answer. Okay, so if I tell you my array size is 4, so array size is 4 means I have players from 4 countries. Okay, so I have players from 4 countries. Okay, so I have players from Australia, England, South Africa, and West Indies. Let's say I have 7 Australians coming, 5 Englishmen, okay, 4 South African, and 3 West Indian. Any random order. So now if I want to form a team whose size is 3, size is 4, let's say. Each team should have 4 players. Team size is, each team should have 4 players. And all the 4 players should be from a different country. So maximum how many teams can I form? Maximum teams possible is, so if the team size and the array size is same, you take the minimum number. So I can only form 3 teams, because if each team needs 4 players and I have only 3 West Indians, so max to max I can utilize these 3 West Indians only. I cannot say that let's take 2 Australians instead of a West Indian. As we have 7 Australians, let's take 1 extra Australian. No, all those 4 players should be from a different national. So if the team size and the array size is same, then this seems very simple, that you take the minimum number from the array and those many teams maximum you can make. So given this data and a team size of 4 players, how many teams can I form maximum? 3. But what if I have 3? What if I have team size as 3? Now how many teams can I form maximum? So we'll have to test it out and check the code. Is it understood, the question, guys? So what I'll try to do is, I'll say that the minimum number of teams possible is 0. And giving this data set, I'll make an assumption that maximum number of teams possible is 10. Okay? So I'm just assuming based on the data. So if they would have given me like this, 70 of 50, 40, then naturally more than 10 teams would have been possible, right? So I would increase my max appropriately. So I would make it 100. Okay, so as per the data, I'm adjusting my maximum. So my min is 0 and my maximum possible teams is assuming over here 10. So first I will find the mid. Okay, so mid means the possible teams. So what is the mid of 0 to 10? 5. So then I will check if mid teams are possible. So considering this data, is it possible for me to form mid number of teams? I will just check. Okay, so this will give me a Boolean value, true or false. So I will at each iteration, I will calculate the mid and I will check if mid teams are possible. So 0 and 10 mid is 5. So if it gives me a true that yes, 5 teams are possible. Okay, now try to understand this. Okay, this is so if it says yes, mid teams are possible, then I will check for is mid plus 1 teams possible. That means it's 16 possible. So if it gives me false, that 5 teams are possible, but 6 are not possible. So I will return the mid at maximum, only 5 teams are possible. Okay. So if 5 is possible and 6 is not possible, so I'll return the mid saying maximum 5 teams are possible. Okay. Second scenario, if it says 5s are also possible and 6 are also possible, then what I will do is I will bring my min to mid plus 1. Now, even 7 teams might be possible, 8 teams might be possible, 9 teams might be possible. So in such, if both are true, I'll push the min to where? Mid plus 1. So now, if 6 teams are possible, there might be a possibility that 7, 8, 9 might also be possible. Okay. Okay. And then if I check the third iteration, now the third permutation, if I check at mid, that mid teams are not possible. 5 teams are not possible. So straight away, I will bring the max to mid minus 1. That if 5 teams are not possible, let's check whether 4 teams are possible or not. So I'll bring the max to where? Mid minus. So I'll bring my max to 4. Now 0 to 4 teams are possible because 5 is not possible. Okay. Sounds a bit confusing. I guess I'll have to break it down again now. Okay, now I'll try to explain again. So once the question is understood, the answer will be understood in a better way. So I will give a range depending on this data. Minimum teams can be possible is 0. And maximum you can assume any number. Okay. I'm just taking 10 to save the iteration. You can say 100 also. Okay. But it doesn't look realistic that giving this data set I can make 100 teams. So I'll just give max of 10. So I will always check at the mid if mid teams are possible. So I will check at the mid. What is the mid? 5. So if it says yes, 5 teams are possible, it gives me a true. So always check for the number of mid teams. So if 5 teams are possible, then I will check are 6 teams possible. So I'll check for mid plus 1 also. Okay. If this gives you a true, then check for mid plus 1. So if mid teams are possible, check for mid plus 1 teams are possible or not. If mid plus 1 also gives me a true, that means even 6 teams are possible. So what I will do is I will bring my min to mid plus 1. Then there might be a possibility of 7, 8, 9, 10 teams also. So my min will come to where? This 0 will now come to 6. Because 5 is possible. So let's check whether 6 to 10 are possible or not. Well, I've already checked for mid. This was my first permutation. Let's check second permutation. If it says yes, 5 is possible, but mid plus 1 is not possible. Mid plus 1, it says no. 5 teams are possible, but 6 are not possible. Then directly I will return mid. Okay, maximum I can make 5 teams. Let's see the third permutation. If it says 5 teams not possible, so I don't have the place to form 5 teams. So I will now check. Let's check between 0 to 4. So I'll make the max as mid minus 1. Am I understood now, I guess? So these things we need to check. So here we are using the logic of binary search. We are iterating in a binary search manner. Okay. Now, how do I check whether 5 teams are possible or not? So to form 5 teams, I need 5 Australian, 5 Englishmen. I need 5 South Africans, but I have only 4 South Africans. I need 5 West Indian, but I have only 3 West Indian. So I will check between 5 and 7, whichever is okay. So to form 5 teams, of 4 players each, I need 20 players. I need 20 players, 20 different players. So now do I have the 20 player? So do I have 5 Australian? From 7, I can pick any 5, right? So yes, I'll pick. So now I'll take the sum of players I have. So I need 5 Australian, I have 7, so I'll take 5. Okay, so minimum of 5 and 7. So it was 0 initially. It becomes 5. I need 5 Englishmen. I have 5 Englishmen. So the sum becomes 10. I need 5 South Africans, but I have 4. So I'll have to choose from the 4 only. So I'll add the 4. It becomes 14 because whatever is minimum. I need 5 West Indian. I have only 3. So I'll say 7. So now my sum of players I have is only 17, which I can form the teams from. But I need 20 players. So now it will return a false that 5 is not possible. Try for a lesser number. And then the permutation will keep on going. Okay. So let's try to code it one by one. Maybe then things should fall into place. So maybe my coding things should become a bit easier. So I have formed a day 6 and I have formed a, okay, so we will say cricket team. So so what do I need to take from the user? The ARR, and that ARR has the number of teams. So 7, 5, 4, 3. Okay. And then I need how many players per team? So I'll say K. So if I say 4. So if I want 4 players per team, and these are my list of players, so how many teams can I form? Maximum 3 teams. Because if I want 4 players, then I have only 3 from here. So these 3 will go 1, 1, 1 in each team. So I'll form only 3 teams. Okay. So now let's check integer max teams equals to, let's calculate max teams and let's pass the array and let's pass the number of teams. And this will give me the number of teams possible. I'll say maximum teams possible is max teams. Save it and let's now create. Okay. So okay. So now what I'll do is I'll take an integer min as 0, integer max as 10. Okay. And as we always do in a binary search, while my min is less than or equal to the max, I'll calculate the mid. So what is my mid? Min plus max divided by 2. Okay. So min is 0, max is 10. So my mid becomes 5. So now I need to check whether I can form mid teams or not. So I will check if mid teams possible. So I'll pass the entire array. I'll pass the mid and I'll pass the number of players I want for team. Okay. And this will give me a Boolean value, right? So let's come over here. Now this function will give me a Boolean value. Okay, so your mid is 5 now. So here you have passed mid as 5. Let's go very, very slow. And here you have passed k as 4. Okay, so we have passed k as 4. That in one team I need 4 players, right? Hang on. So let's try to see this. Okay, so in my array, I have this many players from the team. I want in one team 4 players. If I want one team 4 players, I can form maximum 3 teams, not more than that. Okay, well, I'll just test it out. So minimum 0, maximum 10, min is less than equal to max. Yes, come inside. Calculate the mid. So mid is 5. Now we'll run this through the iteration. Okay. So those who are drawing it with a pen and paper along with me, okay, just be a bit cautious so that you all don't lag behind. Okay. So while min is less than max, what that is 0 less than or equal to 10. Answer is true. I'll come inside. I'll calculate mid. I'll get mid as 5. Now I'll give for checking that is mid teams possible. So in this array, I'll pass. So mid is the number of teams. Okay. So your mid will be possible number of teams. Possible number of teams. This is your mid. Okay. And this K is players per team. Now, if I want to form 5 teams with 4 players, so total how many players I need? So total I need total players needed is 20. So if I have 20 players, I can arrange 20 players. The well and good, I'll say true, else I'll say false. Okay. So now what I'll do is I'll take a sum, initialize it to 0, and I'll say sum equals to sum plus math.min. Okay, I need to run a loop, right? I'll run a loop for the entire array. So I'll run a loop from 10 the entire array. I guess first let me do it, then I'll explain it to you all. So what is in n now? N has 7, but I want only 5. So I'll take the minimum from both. So min of n or how many players I need. Okay. So I'll take a minimum of that. So I can form, I'm telling I can form 5 teams. And my n in the first iteration is 7. So 7 and 5, which is minimum, give me that and add it to the sum. So my sum, which is initially 0, Sum now becomes 5. Yes. And this loop will iterate. This is the next iteration. What is in n? N is 5. Form 5. I can form 5. So give that also. So 10. In the next iteration, my n has 4 and my teams are 5. So 4 and 5, what is minimum? 4. So I'll add 4, 14. The next iteration, 3 and 5. Whichever is smaller, I'll add 17. So now I only have a pool of 17 players. But I need how many players? 20. So I will just say that if my sum is greater than or equal to the total players I needed, I will return true that okay, this team, this team is possible. Else I'll return false. So in this case, when I say 5 teams possible, it returns me false that 5 teams are not possible. Because for 5 teams to be formed of 4 players each, you require 20 players. And I am having a total of only, so from the 7 Australian, I'll choose 5 Australian. From 5 Englishmen, I'll choose the 5 Englishmen. From the 4 South Africans, I can only choose 4. And I can only choose 3 West Indian. So I only have a pool of 17 players. So my sum, if it is greater than or equal to total players needed, I'll return true, yes, 5 teams are possible. Else I'll return false. So now this will return that mid teams are not possible. So if mid teams are not possible, now you reduce your max then. So if mid teams are not possible, then what you do? You reduce your max. So what does your max become now? Your max becomes mid minus. Okay. Twice. Okay, there's no code in the if, that's why. So my max now becomes mid minus 1 and the loop continues. So now what does my max become? So max now becomes 5. 4, right? Because mid was 5. 5 minus 1, 4. Now let's try 0 to 4 teams. So 0 plus 4, mid becomes now 2. So now let's check if 2 teams are possible. Now what I am passing? Mid as 2. Okay, 2 player with 4. 2 teams with 4 players each. So now mid becomes, okay, are 2 teams possible? So to have 2 teams of 4 players each, I need how many players? 8 players. Sum becomes 0. Okay. Now I need what? The first iteration, it is 0. And this is my array. Okay. So I'll just copy it over here. So it becomes easier for me to reflect upon. Okay. So between 2 and 10, what is minimum? You add 2. Between 2 and 5, which is minimum? 2. Between 2 and 4, which is minimum? You add, okay? 4. Between 2 and 4, which is minimum? 2. You add that. 6. And between 2 and 3, which is minimum? 2. You add that. So you have 8 things. Okay, so 8 players are possible. So what is my sum now? So is 8 greater than or equal to 8? It is true. I will return true. Yes. Means 2 teams are possible. So this will give me a true. So if 2 teams are possible, if this gives me a true, then I will check. Let's check if 3 teams are possible or not. So if 2 is possible and 3 also is possible, then I'll check for the remaining. And if say 2 is possible but 3 is not possible, I'll directly return 2. So now here it is telling me 2 is possible. So now I will check if, okay, mid plus 1 teams are possible. Okay. So if mid plus 1 teams is not possible, I will return the mid. And if it is possible, then I will say that your min should become mid plus 1. Okay. And I gave a semicolon over here, so it was doing an X. Okay. Yeah, so this looks good to me. Okay. So this looks good to me. Okay. So yes, so I'm calculating the mid. Okay. Yes, this should. So now 2 teams are possible. So now check for 3 teams whether they are possible or not. So what comes in my possible teams? 3. So I'm passing mid plus 1. And so 3 teams with 4 players each. So I need how many players? I need 12 players. So let's see if I have 12 players available. Sum again becomes 0. Minimum of 3 and 7. 3. Minimum of 3 and 5. 3. Minimum of 3 and 4. 3. Minimum of 3 and 3. 3. So 12. So I have 12 players. So is sum greater than equal to players? Yes, it will return true. So if it is true, okay. So this will give me true. Not true is false. So I'll come over here and say that your min becomes mid plus 1. So what was your min now? The min was 0, right? And max had gone to 4. When I was playing over here in the last iteration. Okay. So your max had gone to 4. And now, and so max is 4. The min is 0. The mid is 2. The mid is 2 now. Now your min become mid plus 1. So min now becomes 3. So is 3 less than equal to 4? Yes. Calculate the mid. Mid becomes 3. Check for if 3 teams are possible. If 3 teams are possible, I already saw, yes, it is possible. So this will give me a true. Now check for whether 4 teams are possible. If I pass a 4 over here. Okay. So if I pass a 4, 4 and 7, what is minimum? 4. 4 and 5, what is minimum? 4. 4 and 4, what is minimum? 4. And 4 and 3, what is minimum? 3. So I'll return 15. So to form 4 teams with 4 players, I need 16 players. But now I only got 15. So this will return you a false. And you cannot form 4 teams. So if it returns you a false, not false is true, I will directly return the mid. That is, only 3 teams are possible. That's it. Okay. And here we have to return. So this was my loop. And this is the while, right? I'll directly say over here, return -1. So if it returns -1 means no teams possible. If it returns -1 means no teams are possible. So I will say over here, max teams. So let's try to put it over here. If, okay, not if over here, I'll directly use the ternary operator. Max teams equal to -1. If it is true, then I'll say no teams possible. Else, maximum team possible is, okay, a question mark over here, right? And colon over here. Yeah. Let's try to check this out and see if it works. Maybe I'll give it a dry run again now, because you have to have an appetite of solving such level of programming, guys. So the difficulty level, I guess, should, okay. So with this 4 teams, okay, let's see how many teams I can form, wherein I have 4 players and all the players should be from different national. So here, as it says, you can only form 3 teams. Let's check it out. It says maximum team possible is 3. If I reduce this and we get 3 players, how many are there? Then let's check it out. Then I can form 6 teams. Max to max, I can form 6 teams, wherein each team will have 3 players. Okay. Let me just walk up to the YouTube and check how these guys are coping up. Else I'll do a try run again. Because the purpose is to understand the concept, not just going through the motion. Okay, Junaid, because you are given an array. Yeah, you see doing the question. N is 4, 3. Okay. So yes, you got the logic as to how we've come to the conclusion. Anybody else? Okay, let's take a different data set and now let's try to operate on that. Okay. So has the questioner given you any data set? Normally they give you a question. Okay, so he is giving you 4, 3, 5, 3. Okay, and he wants 4 players in one team. He's giving you this. So let's dry run this. 4, 3, 5. So how many teams can I form? And one team, okay, will have, okay, here his k is 3, not 4. Okay, and is the size of the array, number of team, number of, okay, and is the number. Okay, so I'll just, where n is the number of countries. So 4 countries are there. And k is the number of players per team. Number of players per team. So let's try to see if I take the data voluminous, you will always struggle. So that's why I'm not taking. Okay, let's try with this 4, 3, 5, 3, and I want 3 players per team. So let's check your notes. I think the answer should be 5. Let's check if the answer is 5. Let me share my screen. Yeah, I'll just share my screen. So I was sharing this part. So I was just checking the data which they are giving the question. So they've told that n is 4, k is 3, and this is the array. So where n is the number of countries, I have 4 countries. So people from player from each country, and k is the number of players per team. So I want a team having 3 players per team. How many teams can I form? The answer is they are given is 5. Let's check if we also get answer 5 from our data set also. If I run this code and check, let's see what answer we get. We also are getting answers. The maximum 5 teams are possible. Now, how did I come to this conclusion? Let's check now. So 4, 3, 5, 3 is my. So I'll reset all my parameters and we'll try to do a dry run. Okay. So try to increase the appetite, guys, of programming and try to conquer such programs. Once you all solve such complex level programs, then gradually you all will get accustomed to. Okay, so let's try this. Oh, so now this is my array 4, 3, 5, 3, 3. So I call this function calculate max team, min and 0. So minimum 0, maximum 10 I can form. So let's check is 0 less than or equal to 10. Answer will be true. Find the mid. So mid is 0 plus 10, that is 10 divided by 2. So mid becomes 5. Mid is 5. So first check for whether 5 teams are possible or not. So I pass the array. Mid is the number of teams possible and K is number of players per team. So I come over here. So what am I checking for? How many teams possible? 5 teams possible. And how many players per team? 3 players per team, right? Now given 3 players per team. So if I want to form 5 teams and 3 players per team, I require total how many players? I require total 15 players. Now, do I have the 15 players available? Can I assemble them? So let's iterate this array. So what comes into n? 4. 4 and 5. Okay. 4 and 5. Whatever is minimum. Okay. Okay. 5 into 3, 15, right? So 4 and 5. What is minimum? You give that. So what will it say? We'll just dry run this. So let's try to add the sum. Sum was 0. Sum is 0. So I'm checking for is 5 teams possible. And I have 4. So I will take minimum from this 2. So I'll get 4. Okay. Then 5 and 3. What is the minimum? 3. So I will take 3. So it will become 7. 5 and 5. I will take 5. So it becomes 12. And 5 and 3. What is it? 5 and 3 is, so I'll take 15. Okay. So is your sum greater than equal to 2 players needed? Yes, true. So I can say yes, 5 teams are possible. So this will return true over here. So yes, 5 teams are possible. This will give you a true. So if this gives you a true, I want to check whether if 6 teams are possible. So now I pass mid plus 1 as 6 now. So let's check. Okay. Now for having 6 teams of 3 players, I need 18 players. But my now total 4 and 6, what is minimum? 4. 6 and 3, what is minimum? 3. 6 and 5, what is minimum? 5. Okay. So I'll say what? 7 by 12. And 6 and 3, what is minimum? 3. So now I only have 15 players and I need 18. I don't have. So 6 teams not possible. So 5 teams are possible, but 6 is not possible. Directly I will say return mid. So this will return you 5. Then the first iteration only this problem is solved. So like this, we'll have to sit and do the dry run to understand how the data has flown internally. So these are complex applications of your binary search. So same logic has been applied over here, just the same implementation of binary search. So anybody who's doing it parallelly with me? Okay, let me push this code to GitHub repo. Let me push it to GitHub repo. The question is in day 4. Okay, I'll copy the question from day 4 also. So I'll copy the question from day 4 here. And I'll paste it over here also. So that we'll have the questions over here also. Again, do a git add dot. Today is day 6. git commit and push the code to the GitHub repo. If anybody is trying, can let me know. And if anybody has any doubts, can share that also. I haven't shared the code editor. I was just checking that. Okay. Now I'm sharing my code editor. Okay. So now I have come to my code editor. I was just trying to debug the code on this file. Now I have come to the code editor. Now you can see my code editor, right? So this was the program of finding how many cricket teams can be possible. And this we are doing using the ternary operator. So we'll okay, this much practice is sufficient for your searching and sortings. Now let's move ahead and let's take the next data structure. Okay. So next data structure in the pipeline is your stack. So on what phenomena does stack operate, guys? Stack operates on which phenomena? Yes, last in first. So if this is my stack, we can think of it as a test tube. Think of it as a test tube with one end is open. So a test tube with one end is open. And if I start inserting marbles into this test tube, I insert a blue marble, and I insert a green marble, and then I insert a red marble. So the order in which they were inserted is the insertion order. First the blue one, then the green one, and then the red one. But the retrieval order or removal order will be the marble which went in last will come out first. So this will come out first, come out second, and this will come out third. So this is the phenomenon on which the stack data structure operates. Okay. And in our Java, we have a predefined stack class. Okay. So we have a predefined class stack. So this is the collection framework. Okay. So I'll tell you all where the stack class lies in the collection framework. So this is the collection interface. Okay. So it's an interface, and all the collection classes they implement this interface. Okay. So there are three child interfaces of the collection interface. Namely, they are list, set, and queue. Okay. So as and when I will need a particular collection, I will explain that and we'll move forward. So as of now, I need the stack. So now I need the stack. So I'll explain about the stack and then whichever interface I need, whenever I'll explain that. And these are all interfaces. And in Java, one interface can extend another interface. And interfaces have implementation classes. So the list interface has classes such as array list, linked list, Java linked list class, and then you have a class called as vector. And the vector, the stack extends from the vector. The stack extends from the vector. So like this. The red line is the implementation. Array list implements list, linked list implements list, vector implements list, but the stack, it inherits from the vector. And these are all in the java.util package. So in the java.util package, we have a class called as stack. You can directly use this class, and this class will add the elements and will work on the last and first dot phenomena. So now if I give you a simple question that to check whether a string is palindrome or not. Simple question. Palindrome using stack. So if I accept a string from user, so I hard code a particular string. Okay, string str equals to. I take a string called madam. Now I want to check whether this string is palindrome. Palindrome means the string which left from right, read from left to right or right to left, either ways will give you the same string. So to add an element into a stack, we use the push function. To remove the element from a stack, we use the pop function. Okay. So I guess these basic jargons you all are aware of. So to add an element, we use push, and to remove an element, we use pop. Okay. So we need to pass the object what we are pushing. And pop will remove the element at the top. So whatever element is there at the top, that will be removed. Okay. So if I have this as my stack, so if I want to populate this stack with A, B, C, so I'll make it a stack and typecast it to a character that it should take characters. So I can push. If I want to push A, I will say whatever the stack object is, stack dot and push and the element I want to push. Stack dot push A will push A. Stack dot push B will push B, and stack dot push C will push C. So this is my stack after pushing will look like. And when I say stack dot pop, now as I have typecasted it to characters, I will fetch it into a character. So what will be in CH now? If I sys out the CH, what should come in CH? CH should have C, right? Yes. I am sharing my paint screen, guys. Isn't my paint screen visible? Now? Yes, is it visible, my paint screen? I was sharing all this all. Okay, so I'll just do a recap. So in the collection in Java, which is in the util package, we have three sub collections, list, set, and queue. So these are interfaces. So we need some implementation classes to implement the interfaces, and these are the classes which implement the list interface. So array list, linked list, vector, and stack is over here. The stack inherits from the vector. Okay, so if I want to do a color coding to this diagram, black sharp rectangle is your interface. Black line is your inheritance. Red rounded rectangle is your class. And red line is your implements. Okay, so I'll just give a key to this diagram. So this is implements. So classes, they implement the interface. This is the class. And this is extend, that is inheritance. And this is the interface. Okay. So the stack inherits from vector which implements the list. And the stack has function push and pop. To add element to the stack, we use push. So if I say push A, push B, push C, so A, B, C is pushed. And stack works on the phenomena as last in, first out. As I mentioned, when you put marbles into a test tube, so you first insert blue, green, and red. But while removing, red is removed first. So to insert into a stack, we call the push function. And we need to pass the object which we are going to push. And the pop function will retrieve from the stack, whichever element is at the top. So if I pop now, red will be popped. And once my red is popped, if I again pop, then my green will be popped. And if I again pop, then my blue will be popped. And once everything is popped, my stack becomes empty. So I have a function to check whether the stack is empty or not, is empty. So if it is true, it gives me, if it is empty, it will give me true. If it is not empty, it will give me false. In this case, it will give me a true. So these are functions we have, push and pop. Okay, so if I push A, B, C, your top keeps on incrementing. It pushes, so top is at the base. And then as you push, you increment the top and you push. You increment the top and you push. Increment the top and you push. While fetching, you fetch and decrement the top. So if I remove, the C is removed. And C is put into this LHS character. So if I display SOP CH, what will be displayed was my question. So now if I display character, what should be the output of my this code? Yes. Revant, Vignesh. File there. So now this concept I'm using over here in my program. So what should be the output of this code? If I try to display this, so now let's come to the coding screen. Okay, I'm sharing my coding screen now. So this is my string. Now, how do I check that is palindrome? So I'll push all these characters into a stack. Okay, so I'll push all these characters into a stack. So I'll take a stack of characters. Let me take a fresh paint screen. Okay, this is my string. Str equals to. Okay, so I'll take a stack of characters and push one character from the string onto the stack. Okay. So first, what will go? M, then A, then D, then A, then M. So how do I write this code now? If I want to, so I'll make a stack of which data type, character, call it as stack is new stack. Plus has been made. Now let's try to push each element over here. So I'll take a for loop, take one character from this string by converting into a character array. So one element from this string will be converted to a character array and taken to ch. And what will I do? Stack dot push character. So after the entire loop iterates, this is my condition of my stack. Now to check for palindrome, what will I do? Let's take a flag. Initialize it to 0. Can anyone give me any particular logic which we can apply? How much elements are pushed? Now what I'll do is, so this is my str, okay? So let's draw the str in red color. So I'll draw this horizontally, and I'll draw that vertically. Okay. So if I run a for loop again, the same for loop, okay? The same for loop if I run again. So now what is in ch in the first iteration? Okay. So I will take two boxes, red box and black box. So what is in the red box? M. So we will pop from the stack. So what will come in the black box also? So as long as these two characters are same, we will move ahead. If I see these two are not same, I'll set the flag to 1 and break the loop and say string is not palindrome. So what will I do? So I'll take a character. If I took over a character ch, I'll take any other character. Let's say character z. Whatever so this red is your ch, because it is a for loop. And this is from the z, okay? Character as z. So I'll say character z is what? You pop from the stack. And always the element at the top will be popped. So what comes under z? Z will also have m. And if these two characters don't match, so if your ch is not equal to z, I'll set the flag to 1 and I'll break. I'll set the flag to 1 and I'll break. And then check after the for loop what is the value of flag. If the flag is still 0, means it's a palindrome. And if it is not anything apart from 0, not palindrome. Okay, so let's check this out and let's code this and see how it works. So I'm sharing my coding screen now. Okay, let me know once you are able to see my codings. Everybody works. Yes, is my coding screen visible now to everyone? Okay, okay, thanks, Vignesh. So now I'll also need a stack. So I'll type code this into character, call it as stack is new stack. Control Shift O from the util package. Okay. Now let's run a for loop. We'll take one character at a time. And what will you do? Just push that character onto the stack. And then again, we'll take the same for loop and pop one character from the stack. Set the flag to 0. And then what do I compare? If the CH is not equal to, suppose that's Z, right? Z, so what will we do? Set the flag to 1 and break the loop. Come outside the loop and check the value of flag. Flag 1 means it is not palindrome. Hence, this out palindrome. Let's save this. Let's check it out whether madam is palindrome. Run JavaScript. Madam, it is showing as palindrome. Change any other spelling. Added extra A. Run. And is not palindrome. Okay. Guys, all good. So basic usage where we can apply stack and use. Let me push this code to GitHub. And let's see what the YouTube guys are. Okay. Try to solve this. I hope my code screen is visible. And just push up the code to GitHub. Okay, done. Give me a 5 minutes reliever and then we'll take the next program on stack. If anybody has any other logic or can refactor this code, can surely do so and share the code with us. Okay, whatever refactoring you want to do. So by refactoring, I would always say use a function. Always use a function. Instead of break, try to use return. Instead of this if else, try to use the ternary operator. So try using the refactoring. See, convert this into a function. Wherever there is break, replace it with return. Wherever there is traditional if else, replace it with the ternary operator. So try to do this enhancement and see if anybody can do it. The basic code I have published. So take that basic vanilla flavor code and try to add how much flavor you can add as per your capacity. Okay, so you have done the refactoring as you can share your code. Let me check. Anybody shared the refactored code? Yeah, output is not a concern. I just want to learn the refactoring of the code. Such a code who's getting the output is not just sufficient. Okay. So what we'll have to do is take this entire stuff, okay, and put it into a function. We'll have to pass the string to that function. Okay. And that will give us a Boolean. So we will put a if across it. And then we'll display the result over here. So let's create this function now. And let's write this code over here. So what will we do? Instead of right saying break, we will just say return false. Instead of all this, what we will say, return true. This tag should be over here. That tag should have come over here. So here, come false. So I'm just checking if no element is same. I don't need the flag over here now. Okay. So this return will do the work of break and will be the return both. So this bracket also is not wanted as the only single statement in it. So I can directly say return false. So I could have eliminated this character Z also. I could have directly checked with this. So I could have directly checked with this. Okay. So if this condition is true, return false. If the loop terminates and there is no false, so it will eventually return true. Okay. And here I'll come and check that if this returns true, so this condition is true, I'll sys out. Okay. So directly we can sys out over here also. So I can just do a sys out over here and check for palindrome string. If it gives me a true, I'll check for a question mark. If this gives me a true, I will say string is palindrome, else I'll say not palindrome. Okay, so I've now refactored the code C. As much as possible, you should refactor your code. That is what we have to take away from these sessions, guys. So I'm writing a function palindrome. This gives me a true means it will show you this. So I'll just add one thing extra and not palindrome. Okay. And this function is doing the rest. So let's say the string madama is madama palindrome is showing not palindrome. And let's write a string Malayalam. Let's check Malayalam is palindrome or not. Malayalam is a palindrome. So this is what I expect you all. Always try to refactor the code. So this code is looking much more sharper now. See. Unwanted variables which were there, I have eliminated it and try to fit the entire code in one single frame. Okay, now let's also check one more question on stack, which is very frequently asked in the interview room. Well-formedness of parentheses. Okay, so is the parentheses well formed? So if I give a expression involving parentheses, curly bracket, square bracket, round bracket, square bracket, curly bracket. Now, is this well formed? Answer is yes. So you will return. So if you give this as input, I want the output to be well formed. And if you give some other input, in order to give the space, I'm just giving the space for the clarity. So I can give without the space. So now parenthesis with parenthesis is fine. Square with round. So there I will get the answer as not well. So these are very typical sort of questions which they ask when they are asking question on stack. So how will we solve this question? Come on. So first let's make a vanilla flavor one. If needed, refactoring. We'll try to refactor the questions whenever necessary. So let's first discuss the algorithm. So what I'll take is I'll take the string and push. So whenever I come across any opening curly bracket, okay. So whenever I come across any of the opening brackets, any of these, okay, this or this or this, any opening brace, okay. So I will push it onto the stack. So first I come across curly, I'll push it onto the stack. My stack will become like this. Then I'll come across square, I'll push onto the stack. And then I'll come across round, I'll push onto the stack. So this is my stack. Now there's nothing more to push. Yeah, this is again a stack of characters. Now the next character is the closing one. So I will switch whenever there is a closing character. So whenever there is a closing character, okay. When there's a closing character, I'll switch it. So how many cases will I have? So I'll have a case for this close. I'll have a place for this close. And I'll have a case for this close. I'll have a case for closing for each. So if I have any closing, I will pop from the stack. So once I get a closing, I will pop from the stack. Okay. So now what do I have? Round bracket. So it will go in this case. And whatever I pop from the stack, let's say I put it into character Z. That should be same. That should be of the opposite type. So if I have this case, Z should be this. If Z is not apart from this, if Z is not this, if Z is not this character, I will directly say flag equals to 1 and I will break. And flag 1 means it is not a valid string. Whatever. Okay. So if it is round bracket and I do not get the complementary of that, I'll say flag equals to 1. When I say closing bracket and I will pop, and if it is not from the opening bracket of this pair, I will say flag break, flag 1 and break. And when I say curly bracket, and if it is not from the opening bracket of this, I will say flag 1 and break. And flag 1 means it is not well formed. So like this, the iterations will keep on continuing. Okay. So let me. Okay. So you all have got the concept, right? So let's try to come to the coding window. Yeah, I've shared the coding window. I hope it is visible. I'll make one more class today. parenthesis match. Okay, using stack, so that you all know when you all open the file from GitHub what it contains. So let me take the string. So let's call it an expression. And let's take the expression as, first let's check for the validness. First let's check for the validness. So here also we will take a Boolean value. Result, and we will check for check validness of this expression. Okay. And now if the expression is valid, it will return me true. So I will say the result equals to true. I will sys out well formed you are able to see my screen, right, guys? Else I'll sys out not well. Now let's go and check this validness. Okay, so check validness. So here also I will be getting a stack. So I'll make a stack and I'll be pushing characters into the stack. Call it as stack. New stack. Control Shift O. And we'll iterate through this expression now. So I would prefer the enhanced for loop. Character CH. I take one from this, convert it to a character array. So what is in CH in the first iteration? In the first iteration, CH has opening curly bracket. So as I said, if anything on the opening will come. So if your CH is equal to either of the opening, it is this. So if it is either from this or it is from this or it is from this, either of the opening, then directly we will push it onto the stack. Stack dot, and then don't do anything else, just say continue. So you will not check for any popping logic, directly it will take the next iteration. Okay, but now, so in the first iteration CH, this is push onto the stack. In the next iteration, push onto the stack. Next iteration, push onto the stack. So now my stack will look something like this. Square bracket, no, parenthesis, square bracket, and round bracket. Okay, and continue. Now when X is which character? Round. So when it comes to closing, okay, so what I will do is I will switch the CH. So if it doesn't go into this if condition, it will go over here And then this will have how many cases? Will have either this case. So first start with the bigger one. So if it goes into this case, what will I do? I will pop from the stack. Let's call it Z. And I will say stack dot pop. So pop will give me, so what will come into Z? So what will come into the Z character? The Z character will have whatever is at the top. So Z will have round bracket. And what is in CH? Okay. CH is having round bracket. Okay. So if my Z and CH both are opposites, well and good. If not, so if my Z is apart from this, so if my Z is not equal to, so if it is your curly bracket, if it is not equal to this opposite, okay, then what to do? This is going to return you a boolean, right? Directly I will return false, and I will say break. So directly I will return false. And now let's copy this and check for the second case. So when if I have a closing square bracket, I will pop from Z, and if it is not from the opposite pair, okay, so let's declare the Z over here so that we have to redeclare it every time. Return false. And similarly, we'll do over here also. The third one, round bracket. If I pop, and if it is not from the opening of this, I will return. Okay. So let's try to run this and check. Okay, program is still semi-complete. I'll try to complete it. First, let's try to explain till here. So let's try run till here. Let's copy the expression below so that we don't have to scroll up again and again. So what is in the expression? So is this on the condition yes push? So this is my stack. This is my stack. So pushed curly. Next is square. Is it from this? Yes. Push the square. Next is round bracket. Push the round bracket and continue. Okay, so this will not go into this switch. Taken a character Z. So switch Z. Okay. So now what is in CH right now? So CH now has a round bracket. Okay, CH now has a round bracket. So we'll go in this round bracket. So pop from the stack. What will it pop? The top one. So it will pop this round bracket opening. So what will come in Z? Okay, so as of now, yes. So CH has round closing, Z has round opening. is Z not equal to this? Z is equal to this. So it will not return the false and the switch will be over and my loop will move ahead. Now which is the next character? Square bracket, close square bracket. So what will come in CH? Close square bracket. Is close square bracket between this? No. So this will not go into if condition. And now switch the CH. So we'll go to this matching case. Pop from the stack. Now what is at the stack top? Opening square bracket. Opening square bracket will come where? In the Z. So Z has opening square bracket. And it says it pop from the stack, okay? And your CH has closing square bracket. So we'll go to which this case, pop it not equal to this, it is equal to this. So condition is okay. Yeah, I'm saying not equal to, okay. So it will condition will become false. So we'll not go in the if. Next character CH will have is closing parenthesis. So CH will have closing parenthesis. Is it among these? No. Switch it. We'll go over here. Pop from the stack. What is in the stack? Nothing. So okay, the last character was in the stack. Pop it. And now your stack has closing. Now I will go in this stack not equal to this. Okay, it's false. So I will not go into this. And now my list is over and my stack is empty. So if my iterations are over and stack is empty means it's a valid expression. So then now check for is the stack empty. So what you do? Return stack is empty. So is empty is a function in the collection to check whether it is empty or not. So the stack empty, true. So if it is true means it will return true over here and it will display it is a well-formed expression. Let's save it. Why is this showing an expression? So I wrote this inside the for. What? I shall written it outside the for. So after the for loop completes, check for the stack. If it is empty, means it is will return your true. If it returns your true, means it is well formed. So this is a well formed expression. Looks like right click, run as Java application, and it is showing not well formed when it is a well formed. Parenthesis round here. So why is it showing not well formed? So if it is true, well formed, else not well. So we'll try to check what is the problem. And I will return stack is empty, right? Okay, so let's check what is the problem with this. Let's try to debug this code as to where the problem is. Character CH. These are all perfectly fine. Case, and case. We need to have a break also, right? We need to have a. Okay, we've given a semicolon after the if condition. So it is not going in the if condition at all. We should not have given the semicolon. Okay, now let's run. Still showing not well formed. So pop from the stack, put it in Z. If Z is not equal to the complementary, return false. Pop from the stack. If it is not equal to the complementary, return false. Pop from the stack. If it is not equal to the complementary, return false. And switch the CH. Yes. And then at the end, check for stack is empty. If it is return true. Directly just check over here if result. Yeah, still it is showing the same. So this is not working. Where do you think we are missing, guys? If it is either of these, I will push onto the stack and continue. If it is either of this, then I will pop. Stack dot pop. And put into Z. Z is not equal to this. Yeah, return false. Okay, let's try to check with this. That is. If I put a break over here, then it becomes unreachable code. If I put a break over here, you have unreachable code. This break will not. Okay, I guess it was going in all the iterations. Okay, we are not giving a break after it. So now it's working fine. Now let's check for the not well formed. Now it is showing that way. Now, can anyone try to improve on this and try to explore as to where we can improve on this logic? Okay, one simple case is if the size of the list is odd, it is not well formed. Directly, I will say if the expression dot length mod with 2 gives me answer as 1, I'll directly say not well formed. Okay, so if it gives me an even, then I'll check for it. Else directly I'll say not well formed. This one corner case I can check. Okay, edge cases you can call them as edge cases. For jumping into the actual logic, you can first check for the edge cases. So this is one of the edge cases. So if I have a string of odd characters, straight away we'll say not well formed. You won't even go and check it. This was one. Okay. What if the string would start with a closing character like this? And then whatever you want to give after that would make no sense at all. So if you can check over here that push and continue, push and continue, push and continue. But if I, after this, so this if should be executed once. If I come outside this if, and I check that my stack is empty. So if I check that my stack is empty, I'll directly return false because we are starting with a closing character because so it has to pass by this if. At least once this if should be executed in the start means your character should start with the opening. So if you're starting with a closing, okay, if you're starting with a closing, so is it from this? No. So this if is skipped. And now your stack is empty and this if is hit and say false. This is so such edge cases you can add. Okay. So let's try to check this out. So if I have the expression, what is the expression? Round. Okay. Like this. See, this is match. Okay. So this is starting with a close, right? Straight away, it will say not well. Yeah, because you cannot start with. So check for the edge cases whenever possible, and then you can work on your programming. Is that making sense? Let me check what these YouTube guys are doing. Yeah, I removed that semicolon after if, and we were not breaking the switch case, so that was a problem. Okay, so I'll check and I'll publish the code. So try to guys increase the intensity of your workout and try to get familiar with solving this complexity level codes, the one which we did for the cricket team one. So binary search, linear search, you can try to go deeper and as deep as possible you want, you can go. Yeah, I'll post the GitHub link again. I'll refresh the GitHub link. I hope you'll have marked your attendance, guys. So I'll post the GitHub link on Zoom as well as the GitHub link on YouTube. I'll post it across both the platforms. Okay, got it? Anyone has any concerns, queries, questions to ask? I have 2-3 minutes. I can address your questions, concerns. Whatever doubts you'll have, you can post it, guys. Okay, so we are moving ahead. We finished with searching, sorting. Okay, we finished with stack. So we finished with the arrays. Now we've done fair bit of stack. Tomorrow I'll take a queue. Okay, and we'll solve some questions on queues tomorrow.
So, dear student, I have an announcement regarding to the time change. So, just I received the update from the team, and from tomorrow onwards, we're changing for the time, and the time of the session will be 7:30 to 8:30. So, please make a note of it and be there on a time for the session. I posted the message over the Zoom and YouTube as well. And additionally, I hope everybody mark the attendance. If not, I'm sharing the attendance link once again. So please mark your attendance and share your valuable. Yes, so the way you are joining the session, same way, same link, all these things will be the same only. Just there is a update in a time. Okay, so over LMS as well, you will find that the session will be starting at 7:30, and same for the YouTube participants as well. Okay. Okay, then. Thank you so much, students, for joining the day 6 of this training program. And we'll see you on tomorrow, sharp at 7:30. Thank you.